load sharing when multi-home to two ISPs through multiple local routers. Load balancing is not possible in a multi-homed environment with two ISPs. Um, and this is an example of that scenario here. This is the network diagram actually. And just continuing, BGP selects only one single best path to a to a destination among the BGP paths that are learned from different ASs, which makes load balancing impossible. But but load sharing is possible in such multi-homed BGP networks on the basis of predetermined policies. Traffic flow is controlled with different BGP attributes. This section discusses the multi-homed configuration that has the most frequent use. The configuration shows how to achieve load sharing. See the network diagram in which the multi-homed of AS100 achieves reliability and load sharing. So let me actually just list this network diagram that I have here in TNS3. Same, almost the same diagram. I think the difference is just uh, the ports used. So here I'm using Ethernet ports, but here in this topology, they're using serial connections between the WAN connections or serial ports. Okay, let me just read the policy, the BGP routing policy. So yeah, so AS100 is, let me just try to, can do it this way. So AS100 accepts the local routes um, from both ISPs along with the default for the rest of the internet routes. The outbound traffic policy is outbound. Traffic is destined to traffic that is destined to AS300 goes through the R1 and ISP link here, this one, ISPA link. Traffic that is destined to AS400 goes through the R2 and ISPB link, this one here. If the if the R1 ISPA link fails, all traffic should go through the R2 and ISPB link. In the inbound traffic policy, meaning that if the ISPs wants to commute to uh, get to this route here, that's the this is the policy. So traffic that is destined for network, this one, from the internet should come from ISPA and R1 link here. And traffic that is destined for network, second network, from the internet should come from the ISPB uh, going to ISPB and R2 link. If one ISP fails, the other ISP should route traffic back to ES1 100 from the internet for all the networks. So I have uh, completed all the configurations on R1 and R2, and they didn't actually uh, put the configurations on ISPA, ISPB, and R6 routers, but I actually just created it myself based on the output here. So let me go through the uh, the policy. So this is kind of edited it because I think this is easier to look at compared to what they have here in this document. So, like I said, this configuration is all done. Okay, let me look at R1. So this command here is basically saying that, um, but this is the what is this? This is the outbound. This is the outbound policy, but you actually it's kind of sometimes confusing or a bit confusing because if you see here, this is the outbound. This is the route coming from or locally originated that is locally originated in AS300. But if you see here, it is being applied. It's applied inbound or incoming. But uh, for the networks that you are announcing to the internet, you are applying it outbound. So I think this is how uh, easier to think about it. So when you actually, in case of R1 and R2, they are advertising. Let me just double check here. Yeah, they are advertising these networks. So um, you should apply it outbound. But when you are expecting, um, you know, other ASs to advertise, or you are expecting routes um, from other ASs being advertised into your own AS, you actually uh, apply that policy inbound, as you can see here. So that's, I think, easier to think about it. So going back, so basically, like I said earlier, this is just basically permitting all the routes, all the locally originated routes in AS300. So that's why you see this regular expression, and um, you have we have this route map and just matching the AS path access list one, and then we set the local preference to a higher value. The default, by the way, is 100. So um, R1 is gonna choose this link to get to this route because of this uh, policy here. Okay, and the outbound policy, um, this is the networks in ES 100. So you are just matching those networks, and we are creating this route maps and just matching this access list here, hence this command, and then prepending you are we are prepending AS path. So we're making this uh, look bad, so that R1 will not, because this is an R1, will not choose uh, will not choose this link here. I mean, will not choose this link. Sorry, we will not choose this link, R1 and ISP link, because we are applying it on ISPA, right? So that three here. But for this route, we are not prepending any AS, so it's gonna have just a single AS path. And let me actually go. on R1 and just verify it. Go into R1. No, I think you should actually go into, we should actually go into ISPA. Yeah, so as you can see here, this ISPA router is choosing this route because it has a single path, AS path. And that's it. It's not choosing the this route here. Well, it's it doesn't have a connection between, it doesn't have a connection to ISPA directly. I mean ISPB. But yeah, so this is the reason why ISPA is actually selecting this route instead of any other routes. Okay. Um, yeah, so here when you again when you apply a policy outbound, you are actually influencing the inbound traffic. And when you are applying a policy inbound, you are influencing outbound traffic. Kind of confusing, but I think you just have to get used to it. And oops, I was looking at R2, no R1. So same as same with excuse me, same with R2. Um, so here we are just matching this AS path access list to make sure that R2 is choosing this link to get to this route instead of any other route, instead of this route here or connection. And it's actually applied inbound because we are influencing outbound. And here, this is influencing uh, influencing inbound traffic. Uh, that's why we are applying it outbound. Okay. Well, I can also show you the BGP table here. No, go to ISPB. You can see here that to get to, hold on, this is not right. This is correct, yes, but this here, how come it's choosing this route or next hop? This is a R6. Let me go here. Ah, okay. So yeah, it's actually correct. It says in the it says in the sorry about that. It says in the routing policy here. So for traffic that is destined for this network should come from should use this link, and traffic to for this network should use this link, which is what's happening here. Let me double check. Yes. And let me go to ISPB. Yeah, it's choosing ISPB is choosing this link here to get to this route or network, and this here choosing this link to get to this network. Okay, actually correct. Um, but going back here, so this is actually correct to get to this route. Let me just, I'm on R1, and to get to this route, I'm using this link or this next hop, ISPA. And to get to this route, I'm using this link. So that's why my next step is R2. So I'm going to, because they have a scenario here that we can try. So I'm going to shut down R1. So this is the link between R1 and ISPA here. So I'm going to shut down. And the expectation is R1 is going to use this link here. So all traffic should uh, go out and come out using this single link because this one R1 and ISPA link is currently down. We just shut it down. So I'm going to just show IPBGP and look at um, this route. So to get to this route, we're using this link, which is correct. And to get to this route using this link, let me actually see if we'll double check if BDP has gone down. Yeah, this the connection, the ABGP connection or peering with R1 and ISPA is currently down. And by the way, this is a nice way to verify whether your neighbor is, whether you have a IBGP or ABGP peering with a neighbor. So here you can see your local AS number, and here in this output or in this section you can see that this one is my ABGP neighbor because it has a different AS compared to the local AS. And this one is definitely IBGP neighbor because it has the same AS as my local AS. And going back, okay, and here is another thing that I want to show you here. So I will go into R6 and just show IPBGP. You can see here that, let me just show the topology. So to get to this route, I need to go here, which is not correct, I think. So let me just, yeah, it's not correct. Let me just clear the BGP session. So the BGP table will get updated. Okay, now before uh, to get to this route, we need our next hub was ISPA, but now it is ISPB. You can see the IP address. And to get to this route, next up is ISPB also. And I think it's this one is fine. To get to this route, next up is ISPB. So that's all I. Uh, that's how you can actually load share or do a load sharing when multi-home to two ISPs through multiple local routers. So load sharing when multi-home to two ISPs using different AS numbers, and you are using multiple local routers. That's the scenario that we just look at. So yeah, that's all for this video. I will see you on the next one.